Okay, guys, if you're watching this now, chances are you have just completed your first practice ACT for our summer series, or you are at home and you're looking at this to try to help yourself improve your score. That being the case, I want to begin this first video with some hints that I found in this new Kaplan book that I ordered from Amazon and got in last week. So I want us to look at these helpful hints. I'm going to point some out to you as we go, but please read these hints. You want to be able to pull out every possible point you can from your ACT test, so these little helpful hints can help you pick up a point here and there. So please read them carefully. I would read them often over the summer, and I would certainly reread them the night before I take my ACT. Okay, like I said, this is the new book, the new ACT from Kaplan, and it is not just math. It has both English and math, although all we're going to be talking about this summer is mathematics. Okay, let's move on and see what some of our hints are that they share with us. Here we see that in our first section of math, or the first introduction they have to math, they point out some things that we want to make sure that are clear in our mind. First of all, the math test is 60 minutes long. So you're looking at about a minute per question because you have 60 questions. So anytime you practice over the summer, if you're going to sit down and work 5 problems or 10 problems or 3 problems or 20 problems, time yourself with a minute per problem that you're going to work, because you want to establish a pace. You want to know what that minute feels like. You want to get a good feel for that, so on the test you've established a good pace and you don't let time run out on you. Notice also that they tell us that all the math questions have the same basic multiple choice format with a standalone question. You may encounter a set of 2 or 3 questions that share a table, a graph, or other relevant information. The questions cover a wide range of math topics from pre-algebra to coordinate geometry. You want to think of that as graphing, okay? And a little bit of trigonometry. You're going to have more earlier level math skills as order of operations, working with variables, solving basic equations in geometry. You'll have less, and they didn't say none, they just had less on sequences, logarithms, and matrices. All right, let's see. Test day, directions, and format. They've given you a list, or I don't want to say a list, they've given you the directions. So you can read these. You can read these right here. And you can establish in your head how you're going to choose these. Now look, you may use a calculator on some you can't on the SAT, but we're looking at ACT, so you're going to make sure you have your calculator. You want to make sure you have fresh batteries. You want to make sure that you're charged up when you go in there and you're ready to roll. I particularly like this bit of information they've given you. Unless otherwise stated, figures are not drawn to scale. Geometric figures lie in a plane. If you've had geometry, you know what that means. It means they lie on the same flat surface. If you're about to have geometry, that's one of the first things we talk about. The word line means a straight line, and the word average means arithmetic mean. All right, let's see. I'm trying to see. I think we're ready to look at the next page, but go ahead and read all the rest. Okay? Make sure you read this. Again, this is timing down here. Make sure you know about timing. The ACT test is designed to measure problem solving and logical reasoning along with basic skills. Covered topics include. Now, if you know you have a weakness in any of these areas, please let us know, and we are happy to help you come up with some other problems to help you practice on these. Unit conversion, I don't believe that is between systems. I don't think they have you converting anything between like metric and changing over to English. I think it's within the English system and within the metric. Let me just say, at this time, I have not seen that. But if we see that, we will meet that need if we need to. And again, they said, you know, a little bit of trig, a little bit of stats and probability. Something else I want you to read. I'm sure Mr. Shorey is going to talk to you about how he's going to score your tests. We're going to score your tests each week, and we want to you to compete against yourself. You're not competing against anybody else. You just want to try to do better than you did on the previous test. And that's where the competition comes in. So don't worry about what somebody else is making. You just worry about improving on your own score. More for you to read. I pulled out just these things that I thought would be helpful to you. The essential skills, and we're going to talk a little bit about those and some examples I give you today. Numbers and operations, rates, percents, proportions, expressions and equations. Okay, this is very important. Your higher math, 22 points. Okay, look at all of these different things so you can enjoy those things that you know are your strengths and you know where you need to target to improve your weaknesses. The test maker has indicated more than 25% of the test will involve modeling, but don't let that intimidate you. Modeling just means using equations, graphs, diagrams, scatter plots to represent real-world scenarios. Okay? It's a lot of like understanding word problems and so forth. Don't be afraid of that. You can do it. Okay, I think these are really important for you to know, because if you don't understand what they're communicating to you in the directions, it's going to be hard for you to be confident in working the problem. So please note these number properties that they share with us. These are really important. Integers include 0 and negative whole numbers. We're going to talk more about that in a few minutes. Include 0 and negative whole numbers in evens and odds. In other words, 0 and negative 2 are considered even on this test. Negative 1 is considered odd. Prime numbers do not include the number 1. Remainders are what are left over, or what is left over when you are dividing. Okay, they give you an example here. What should you say if 15 divided by 2 is 7 with the remainder of 1, then they want that 1. They don't want an answer of 7.5. And I think this is critical because of the way that we teach Algebra 2. The square root symbol represents the positive square root only. You may remember that as called the principal square root. So in the equation x squared equals 9, we know it has two solutions. But when you see the square root of 9 on this test, it means the positive 3 only. I think these are very, very significant for you to spend some time with to make sure that they don't catch you in some little technical issue. We have some more vocabulary that I know is not exciting, but it's things that you need to look over, probably things you already know. Remember what a factor, a multiple, because they will use these words in the directions, and you're going to need to know what they're referring to. So as you come across these this summer, we want you to ask us and keep those in the notebook that Mr. Shorey has asked you to keep. Okay, two integers are relative primes if they share no prime factors. Okay? So you would look to determine whether two integers are relative primes, break them into their prime factorizations. For instance, 35 is 5 times 7, 54 is 2 times 3 to the third. They don't have any factors in common other than 1, and we've already said that we don't consider 1 prime on the ACT. So since they have no factors in common, they are relative primes. You don't see that very often taught in elementary or middle school anymore. So that may be a new term for some of you, the relative prime. So keep that in mind, okay? Now, I will have attached a copy of this worksheet. There are 10 problems to the Google Classroom. If you haven't worked them by now, please turn the video off. Take 10 minutes and work those 10, and then come back to us, and we're going to work these together so that you know if you got them correct or not. All right? If they were easy and you don't need to listen to the video, that's fine. Be honest with yourself and be your own judge. But as we go through here, I'm going to try to point out some things that these problems make me think of that I want you to make sure you remember before or as you take ACTs. Okay? So you will be given 10 minutes to work these problems because I've given you 10 problems. As you practice for the ACT or the ACT, allow you a minute per problem. Okay, so if you want to stop now and work the problems, the 10 problems in 10 minutes, it'd be a good idea to do that now. Okay, let's look at problem number 1, which is number 4. I wanted to keep the numbers that were on the problem in the book so that if we had to reference the book for anything, I would easily be able to locate the problem. But here we have, if 3 to the 0 power equals quantity 1 minus n to the negative third power, then n equals, okay, things that we have to remember here. We need to remember that any number to the 0 power is equal to the number 1. Okay? So I'm going to have that 1 equals the quantity 1 minus n to the negative 3. We also need to remember the definition of a negative exponent. A negative exponent, any number raised to a negative power, is 1 over that base raised to a positive power. Now we can also look at that from a different viewpoint. If I have 1 over a number to a negative exponent, that's the same thing as if I move that particular quantity from the denominator into the numerator, and then I can make my numerator a positive exponent. Now, along with knowing that my rules for negative exponents here, also I use 2 words. Make sure you remember numerator and denominator. The numerator's on top, the denominator's on the bottom. For any of you who are still having trouble remembering that, remember the D in denominator means down. Okay, so the denominator is down, the numerator is up. Okay? Also, as I look at this, I'm reminded to also remind you that remember that you can take a cube root of both sides of an equation and a square root of both sides of an equation. I'm not saying that's what we need to do here, but when I'm looking at that cube, it just reminded me of those skills that I wanted to remind you of. So those are just some things to remember that this particular problem reminded me of. All right, I've got my quantity to a negative exponent, so that means that my 1 equals 1 over the quantity to a positive 3. All right, now as I think about this, I know that only 1 over 1 would give me the number 1. Only 1 over the number 1 would give me 1. So I know that this 1 minus n cubed has to equal to 1. Now, if I want to, I can take A, B, C, D, and E and plug in those numbers and see which one works, because only one of them is going to work. But if I'm more mathematical, more algebraic, then I could also take the cube root of both sides here, and I could say that my 1 minus n equals 1. And then as I solve, adding and subtracting, multiply, dividing, the same thing to both sides, I'm going to get that n is 0. Now, do not hesitate to plug in and see if they work. That is perfectly great in these. I think that the best advice I can give you when do you plug in and when do you try to work it out might be the time that you have left. So if it's faster for you to plug them in and see, that's what I would recommend. If it's faster for you to work using a method, then that's what I'd recommend. Or actually, the best thing would be, if you had time, do both and see if you get the same answer. That would even be better. So you may want to do one way and come back and check another. All right, let's look at number 9 here, which is the second problem on your chart, or on your sheet. I'm going to work this using my order of operations. Let me use another color to separate this work. Okay, so I'm going to have 1 plus the square root of the opposite of negative 5 squared. Now, it's my quantity there, that negative 5, just that piece is going to be squared. So I'm going to have minus, now negative 5 times negative 5 is positive 25. But that negative comes on down. Okay, because that one wasn't squared. Now I have a negative under my square root. That means I'm no longer working in the real number symbol system. I'm in the complex numbers. So here I have 1 plus the square root of 25 is 5, and the square root of negative 1 is I. So I'm going to get here D for my answer. And I believe up here I didn't. I should have gotten C. Okay. Now, this reminds me to review the concepts of I. Remember the complex number. If I have I to the first power, that means I just have I, or the square root of negative 1. If I have I to the second power, then I have negative 1, because I have multiplied the square root of negative 1 by the square root of negative 1. That lifts my radical and gives me my radicand back, which is negative 1. If I have I to the third power, that would be negative 1 times I, or negative I. And then I to the fourth power is 1. Then my pattern starts all over again. So if you'll see how this works, let's see if I can get me a highlighter in there. If I see how those work, I have a pattern that goes I, negative 1, negative I, 1. Now, how can I remember that? The way I remember it is I remember that my negatives are the two on the inside, and my positives are on the outside. So positive, negative, negative, positive. Then I think of a little child when I try to think of what goes with the negative and the positives. See how this is I won, I won. Can't you hear a little kid saying, I won, I won? So that's the order they go in. I won, I won. So plus I, negative 1, negative I, plus 1. That's your pattern. Now, as you go through that pattern, that's going to be helpful to you, because sometimes you're going to be given a problem such as, let's say, I to the 27th. And I want to know which of those 4 values that I have highlighted in red over here, I to the 27th, is really equal to. Well, the easy thing to do is, since there's 4 numbers in my cycle, divide the exponent of 27 by 4. Now, you'll always take the exponent of the number, and you're going to always divide by 4. That 4 doesn't change because of the 4 items in my cycle, the I won. So I divide this out. 4 goes into 27 6 times, and I have a remainder of 3. It's the remainder we want to look at. If your remainder comes out to be 1, okay? If your remainder is 1, then you're going to have I to the 1 as your answer. If your remainder is 2, then you're going to have I to the 2 as your answer, which is negative 1. If your remainder is 3, like we have here, then I to the 3 is your answer, which is negative I. And if you have, would you have a remainder of 4? You would not, because 4 would go into 4 evenly. So that tells me if I have a remainder of 0, then my answer is I to the 4, which is plus 1. Okay? So that's just a little review quickly of the complex numbers, because this problem reminded me of complex, and I said I was going to use these problems to help us do some review along the way. Okay, let's look at number 10. Okay, I've got two to the negative 1/2 to the 4y equals 1/8. I've got a power to a power. When we have a power to a power, we always multiply our powers. Remembering the rules of exponents is really crucial. Exponents are slapped all over this test. So make sure you know when you multiply like bases, you add exponents. Divide like bases, you subtract exponents. Power to a power, you multiply powers. Anything to the 0 power is the number 1, etc. And we'll look at more as we go through the summer to review. But make sure you have those in your head. Now, since this rule is true, that means here I have a power to a power. I need to multiply those powers. So I get 2. Okay, negative 1/2 times 4y is going to be negative 2y, isn't it? Now, I could take a logarithm of each side here. But some of you haven't had that yet. So what we'd like to do we did this in Algebra 1 this year, and I don't know what all your backgrounds are, so I don't know which textbook you've had and which Algebra 1 class you've had, but when you have a problem like this, we advise you to change that 1/8 to 2 to some power. You would like to have those powers or those bases to be the same. So since 1/8 is the same thing as 2 to the 3rd power, now I have an equation and they have like bases. Since the like bases are equal, I can set my exponents equal. So my negative 2y has to be 3. And divide each side by negative 2. Excuse me. I'm going to get, wait a minute, let me change this. It's a negative 3. Sorry. So now divide negative 3 by negative 2, I'm going to get 3/2. Since this was a negative exponent, I had to flip. See, I had to flip that 8 up, and that became 8 to the negative 1st power. So that means I had a negative exponent there. So here I have 8 to the 3/2. Okay, so that is what my y is going to be equal to. And that is D. Okay? All right, we got 3 more on this page. Let's see what we can do. This one, the thing that is reminded me to remind you of is to make sure you answer the question that's been asked. On this one, it doesn't ask what the value of m is. It asks what the value of 8m is. So don't get caught up in answering the wrong question. So be careful on one like this. So I've got here m to the negative 3rd equals 64. Now I wonder if I can get 64 to equal something to the 3rd. I'm trying to get something that's as alike as I can. 4 to the 3rd is 64, and having your calculator right there would be easy for you just to punch in numbers until you find what to the 4th power is 64 if you don't already have that memorized. All right, but I've got a negative exponent here and a positive exponent here. So remember that I would like for the bases to be the closest they could. If I wanted to get a negative exponent, I could make that 1 over 4 to the negative 3. And that is the same thing as that guy right there, according to your exponent rules. So m to the negative 3, m is going to be equal to 1/4. But we're not done. But see how, look what they did right there. They gave me that. So it's really easy when you're under stress and you're trying to go quickly, just to go ahead and put that 1/4. But that's not what these sneaks ask us for. They ask us for 80m. So that means I've got to multiply 8 by the 1/4, multiplying a whole number by a fraction. Make sure you know your fraction rules. I'm going to get 2. So my actual answer to the question that was asked is D. That's 2. Number 16 is a critical thinking problem, a word problem. Don't let these scare you. There are 45 students signed up for the performance band and 35 for the jazz band. So 45. Well, let me see. Let's see if I can get, there we go. 45 for the performance band, and there's 30 for the jazz band. 19 students are signed up for both bands. So how many is only signed up for one? Well, that means that in the performance band, 19 of those kids are in both bands. So let's take that out, and we see we have 26 that are just in performance band. That same 19 are over here in jazz. So if I take those out of the jazz band, the 11 left are only in jazz band. So how many signed up for only one band? That would be my 26 in performance plus my 11 in jazz. And 26 plus 11 is 37. So that should give us C. Number 17, we have a defined operation. Now, our operations that we use in our math system are adding, subtracting, multiply, dividing, right? Well, this is an operation that they invented or came up with. A circle dot B equals 2A minus 3B for all integers A and B. So what is negative 2 circle dot 1? Well, if negative 2 circle dot 1, and my negative 2 goes anywhere that there's an A, and then my 1 goes anywhere there's a B. So I just replaced my negative 2 and my 1 over here for where there's an A and a B. Now I'm going to work this out. I get negative 7. That is A, and that's correct. Okay. Usually you will see 2 or 3 defined operations, or it's a mathematical process that you perform on 2 numbers. They define the operation. They come up with a new operation for you. Okay, I think we have another one on the sheet that I gave you. Let's move along. Okay, these are the last problems. 21, we've got power to a power. Excuse me, again. So remember here, kiddos, that if I have this whole quantity raised to the 4th power, that this means that I must take my whole number and raise it to the 4th power, as well as my variable. That 4th power belongs to every factor inside the quantity symbol. So 2 to the 4th power, 2 times 2 is 4, times 2 is, that's going to be 16, times power to a power, you multiply. So 16m to the 12th. Did I answer the question? I did. So E is our answer. I'm not sure about this, but I'm thinking that the English section may just have A, B, C, D, but the math has 5 answers, A, B, C, D, and E. So I think English just has 4 and math has 5, but y'all can look that up. I guess it really doesn't matter, but I'm thinking that that's the case. Okay, 23 is one that I wanted you to look at as realizing that you need to know your sets of numbers, and also how important it is to look for patterns. But with the sets of numbers, this says that positive integers positive integers. So we need to know that's the only set we can use. So let me review real quick our sets of numbers. We have the natural numbers. Those are just our counting numbers, 1, 2, 3, 4, 5, 6. Okay, that's the smallest set that we use. Then after that, we have the whole numbers, and all the whole numbers does is add 0 to our set. Then when we put the negative wholes, that gives us the integers. So with our integers, we don't have any fractions yet, no decimals. It's when we add the rationals that we have decimals and fractions. Okay, so remember that that's how our set of numbers go. So in this problem, we're only using our integers there. Sorry about that, I meant to highlight. All right, so we want to know numbers that add up to 21, and we want to find the smallest possible value when I multiply those two numbers. Okay, so I'm just going to start making a list. 20 plus 1 is 21. If I multiply them, I get 20. Okay, 19 plus 2 is 21. If I multiply them, I get 38. 18 plus 3 is 21, but if I multiply them, I get 54. What's happening when I multiply these factors as I go from 1, 2, 3, 4, as I'm getting a larger number here, what's happening to my products? They're getting bigger. And they asked us for the smallest possible value. So it looks like that 20 is going to be the very smallest we can come up with when we multiply two numbers that add up to give us 21. You can keep going as far on that list as you want to. You can do the whole list if you want to. If you're not comfortable that maybe the pattern might change. But in this case, I'm pretty comfortable with the fact that we're going to get 20. Even if you want to go to the middle, the closest, do 10 times 11. When you get to the middle of this, you're still going to have a much larger number. So whenever you're convinced you've got a pattern, that's when you can bail on that particular problem, okay? 27 gives us another made-up operation, a mathematical process that they're performing on two numbers. It's x triangle y, or we can say x delta y. It's what we prefer as mathematicians. So if I have 7 delta negative 2, and delta is defined as taking the first number, adding 1, and then dividing by the second number, then I'm going to have 8 over negative 2, which is negative 4. Remember how in the material we looked at first, it talked about how order of operations is a significant test point that they want to make sure you understand. All right, on number 30, we're going to, okay, if you put this in your calculator as square roots, you're going to get a decimal, and that's not going to help you pick the answer that they want unless you test each one of these to see which one of these is the decimal that matches the one you got. So an easier way to do this would probably be to simplify each radical. Now remember what simplifying a radical is. When you simplify a radical, you make sure that you have no perfect square factors under the square root symbol. Okay? So when I look at the square root of 48, I see that it is 16 times 3. 16 is a perfect square factor of 48. So although the square root of 48 is a nice number, it's not considered simplified, just like 2/4 is a nice number, but it's not simplified unless we call it 1/2. So what I do here, I'm going to take the square root of this 16, it becomes 4. So really the square root of 48 in its best form and the most proper form is 4 on root 3. Now let's look and do 27 the same way. It contains a perfect square factor of 9. The square root of 9 is the number 3, so it comes out But the second 3 has to stay under, doesn't it? So really, when I have the square root of 48 minus the square root of 27, I really have 4 roots of 3, and I'm subtracting 3 roots of 3, so that's leaving me 1 root 3. And remember, I don't have to have that coefficient of 1 there. I can just make root 3 my answer, which in our case is C. So we simplified radicals there. We combined like terms. We made sure we pulled out perfect squares. We had to know what factors were. So there was a lot of information packed into that little problem that they could check to see what you were remembering. You cannot ask the proctor of your test a definition. You can't ask them anything. So if you come up with a problem that has some vocabulary in the instructions and you don't remember it, then it's a possibility you may miss that problem. So you want to make sure that you're clear on your basic vocabulary. Okay. That will be it for this video, and we'll do another one next week. This one was on number theory. We may do another number theory. If not, we're going to jump on to geometry. Have a good week, everybody.